Start. Hi all, my name is Vojin Jovanovic and I work in Oracle Labs in the GraalVM team. Today I'm going to first of all thank you all for coming, and I'm especially glad that my little son is here first time to see me present because it's in his hometown. That's for David. And today I'm going to talk to you about GraalVM and how you can run Scala faster with GraalVM, which is kind of known already, but I will just confirm that with the new results. And then I will talk to you about a new thing that we did in the last 6 months, and that is running Scala faster with GraalVM on any platform. So for those who don't know what GraalVM is, this is probably the slide that summarizes it best. So GraalVM is a virtual machine or a language runtime, which is built on top of the Graal compiler, and it enables to run many languages. So it's a polyglot runtime. And here on the slide, you can see you can run languages like Java, Scala, and Kotlin. But then together with them in the same runtime, you can run dynamic languages like JavaScript, Ruby, R, Python. And then what's really cool, you can also run all of the native languages because we support the LLVM interpreter. And then on the bottom of the GraalVM, so in the middle, there is a Graal compiler. And then on bottom, you can run that on the top of Hotspot, just like you do Scala. Or you can run it as a Node.js application. You can run it inside of databases and other native platforms, such as Oracle Database or MySQL. Or you can run it as a standalone shell script. Okay? And we'll add a bit more today on this, to this picture. So what's really in the core of this GraalVM? So I won't have time to go into the details, but the core is the Graal compiler, right? It all revolves around it. And what's the key difference of the Graal compiler to the others is a few things. It's written in Java, right? So the previous compiler, C2, was written in C++, and it was essentially very kind of entangled with the VM, with the hotspot VM, right? And then Graal came, and it was written in Java, and it had a clear separation, a clear interface to the VM. So it kind of became very modular, maintainable, and extensible, right? So you can plug in a new phase, you can refactor things, so it makes development really easy. And the Graal compiler comes in 2 flavors, which we'll see in all of the graphs that I showed throughout the presentation. So there is a community edition, or short CE, which is essentially the open source part of the Graal compiler. And there is an enterprise edition, which adds a few advanced optimizations, which we will basically add to the performance, right? And our general goal is that, the API of the GraalVM doesn't really change whether you're in like community edition or an enterprise edition. It's just, the performance. And then, because of this nice kind of nice interface and modularity and extensibility, it was very easy to develop really cool optimizations, right? So what makes Graal faster, I would take, there is a lot of them, right? But I would take 3 out as which I like the most, which is partial escape analysis, path duplication, and priority inlining, right? So these 3, I think, make Graal kind of unique compared to the other compilers, and especially how they interact with each other. So if you want to know more about these, you can go and look at the papers, they're published. But in short, if you have something like this streams operation that you see on the top here, essentially what Graal will do is, that's what everyone programs today, especially in Scala. You just do collection operations, high level. What Graal will do, it will, with the combination of all these optimizations, produce, in the end, something like this while loop, right? I actually measured performance. I looked at the graphs and measured performance. And it's actually not quite there yet. There's a few % difference. But what you will get is essentially just like writing a while loop. Okay? So that's the core of the GraalVM. And why is this good for us? Why are we talking to the Scala community now? Right? Well, the Scala language has many abstractions. It's kind of modern. And you write in a very high level. You explicitly say what you want to do, and it happens. And in these cases, GraalVM is especially good. Right? So here on this graph, we essentially, and the problem with all the benchmarks before that kind of show the performance of virtual machines and languages was that they were kind of written for this old school style of programming in Java, where you have like big functions with while loops, and then if you inline those, it doesn't really matter much. But that's not actually what's written today. So What we've done is we developed this new benchmarking suite called Renaissance. And essentially, it kind of needs to represent more what people write today, right? And if you look on this graph, essentially, most of the graphs will be just speed up on the left, and then you have benchmarks on the bottom, and then you'll have a speed up for the individual, and you'll have a geo-mean at the end, okay? So that's the geo-mean is actually what you really care about in the end, right? And here we have Graal EE and CE, which we've seen on the first slide. And on the y-axis is the speed up, right? So, and when you look at this Renaissance benchmark, which kind of represents what people write today, especially in Scala, you will see that we get the geo-mean of 32% improvement, right? So if you run your program with Graal EE, you will get 32% improvement. And if you run it with CE, which we'll see shortly how easy it is, you will get 6%, right? And then there is a specific Scala benchmark, which is just for Scala, and it has a lot of like tools and stuff from the Scala ecosystem. And here you will again see 38% for Graal Enterprise and 7% for CE. And because of this, Twitter is already using it in production. So when you tweet, you know, the code that dispatches the tweets around is running on Graal. It was generated by Graal. So, you know, this is a solid technology. It won't fail on you. And then before, you know, there were people who are always kind of, there was one problem that the Graal was written in Java, so people would always say, well, yeah, but then it starts slow and so on. And in the last year, what we developed is a library called libgraal, which just takes the whole Graal compiler and compiles it as a native library, right? And then puts it as a JIT compiler in Hotspot. So here on the, essentially, and then we package it as a native image, which we'll soon see what it is. And every compilation is kind of a separate thing. So you just compile a function and throw away the whole heap, and you start over, right? And essentially, what you see on the left, you will see that, you know, on the right is what happened before. This is a simple streams example that I composed. You will see that essentially on the first run, it would take a second to do a first iteration, and then it would like slowly get to the performance. On this side, you will see how it kind of, you know, immediately goes to essentially kind of right from the get-go, it becomes fast. And when you run this with C2, it's basically pretty much the same numbers, right? So now we have with the Graal compiler, you will, whenever you run your app, it will run as fast as C2. I mean, it will warm up as fast as C2. Which brings us to the next point. It's essentially using GraalVM for faster compilation. So the Scala compiler is notorious for essentially being very slow to compile. Like every Scala Days I visited, people would be like, oh, it compiles slow, it compiles slow. So what we've done here is we used Graal for compilation, because for compilation there is another particularly important thing, is that it's not only the number of machines that run somewhere in the cloud, which you don't see, it's actually your time, right? Compilation, whenever you do CI or tests, compilation is the first thing you do in a static language. And because of that, it's your time. You wait for it, right? So you want this time to get shorter. That's why on these slides, lower is better. Basically, it's the time, essentially, to compile. And then on the graph, you'll also see I took numbers from the three big projects. One is the akka, Lichess, which is written in Scala, and the frontend for Guardian. And then we compare like running with normal Java, Java 8, running Java with GraalVM, and here I'm using Enterprise Edition only, no Community Edition, because in this case, I think it's, you know, your time and your productivity, so, you know, money doesn't really matter. And essentially, and it's not expensive for this case. So essentially, and then we use Bloop, which is a new framework for Scala compilation, developed by George from Scala Center. And essentially, we'll use Bloop and Bloop plus GraalVM. And there are other frameworks to speed up Scala compilation, Hydra, and the numbers for them are pretty much the same. And so if you look at here, you know, compared to normal Java, you will get anywhere from like 30–25% speed up, right? So you will go and you will get your results faster, 25 to 35%. And then also if you apply Bloop, which kind of parallelizes the Scala build, you know, in this case actually pipelines and parallelizes, you will get the similar improvements. I mean, here you don't see that much because the first number is smaller, but you will get pretty much the same speedups. So any compilation framework you use, is it Hydra, which is commercial, or Bloop, or Scala, you will get about 30% faster compilation. And that's your time, right? So, and so this brings me to the conclusion of this first part about Graal, running Scala faster with GraalVM is essentially using C2, like the compiler in Java instead of Graal, is just a waste of time and energy and money, right? So it was just wasting 7% of your performance. And all you need to do is basically, for JDK 11, put this on your command line, and that's it. 7% for free, done, right? Or you can download GraalVM CE or EE and put it on your path in Java home. It's that easy. So, and it runs at Twitter. People are already using it for compilation all around. So there's absolutely no reason to not use it. It's just throwing money, time, and so on out the window. And then in production, it will give you about 35% speed up, which is, if you have a service running 1,000 machines, multiply the numbers. It's a pretty cool thing to do. And then, of course, for compilation. For me, this is like a no-brainer. You have a team of 100 people waiting 30% more for something, and you have like 1 or 2 or 3 machines or 5 doing CI. It's just like a no-brainer. Get your stuff done faster. Cool. So that was the part about Graal, running Scala faster on Graal. But then the JVM is also notorious for its slow startup, right? So we developed under GraalVM, we have this essentially project called Native Image, or people call it GraalVM Native Image or just Native Image, which allows us to run Scala with fast startup and low memory footprint. So how does this work? On the left side, we start with just like a Java. You say Java, there's CP, and the main class, you do the same, right? So you will have your application libraries, Java class library, and you will have something called Substrate VM, which is a VM developed in Java that we will kind of ship together with all your libraries. And then what we do inside of Native Image is we do an iterative analysis. It's a variation of a points to analysis, which will kind of try to see which code from the, all of these is reachable, right? So with what are you using, and even if you're not using some fields, it will just kick the fields out. You don't need that, right? And then it runs iteratively, and another interesting thing it does, it pre-initializes your stuff. So essentially, you can kind of run parts of your application ahead of time. If you need some configuration, or if you need some parsing some files, which takes a lot of time, you can essentially come and you can just do that at build time, and then it will produce, it will be kind of serialized in the heap, right? And then we will AOT compile the code and take the snapshot of this heap, and we'll use the Graal compiler, of course, for the same thing, and produce machine code, right? So you will get machine code, there's one object file, image heap is another object file, link them together, you get an executable. And this executable, or a shared library. So, and this executable you can run just like any other native executable on pretty much any platform. Okay, so Windows, is it Windows, Linux, or Darwin, or you will, and also we support ARC64 and AMD for now, but more is to come. And yeah, so what you get with this, so how does this work? It's really easy. Scala C hello world, time hello world, 70 milliseconds to print like one line. That's a bit ridiculous. And then if the native image, you pass the library. We could make this a bit, maybe we should do something like there's tool Scala to make this nicer. And then you say hello world, this is now just like a C program, and you get 5 milliseconds, okay? And now, why is this interesting? Is because these days, it's like microservices. Lambdas are becoming very popular, and there's a whole ton of these frameworks, essentially, for microservices. And what happens in the cloud is that basically people are, the cloud providers are kind of removing your services if they're not started up, right? And so when the new request comes, the service needs to boot, and then your whole VM needs first, the kernel needs to start, and then your VM needs to start, and that takes a ton of time. And here on this slide, we have the startup time for some of the frameworks. These are not Scala frameworks. I'll talk about this later, but they are very popular in the community. So for Helainen, So we'll have, again, JDK8, JDK12, and native image, right? And we have like Heliden, that's an open source framework developed in Oracle for microservices. You will get like 1 second on top of the boot time of the kernel itself, right? So it's about 1 second with native image, 35 milliseconds. So you basically start, and it just like, starts, answering requests. So this means if your Lambda is called and you get the request will be out before you break your service level agreement, right? Your customer won't have to wait for like a second to get the page. And similar thing for Micronaut and Quarkus, which is entirely based on GraalVM, you get 16 milliseconds, right? So it just, service up. And then another thing which kind of saves money is basically the memory footprint, right? Because now you don't have a JIT compiler, you don't have an interpreter, you don't have the class information. It's all kind of burned into this binary in a very minimal and compressed way. You will essentially, the memory footprint for essentially running the first request on these applications, it will be about 120 megs, 170, 180, and with native image, it will be about like 4x less, right? So you'll get 30, 40, and 17, right? So, and now, you spend like less memory, which means it's cheaper, right? So that's it. Good. So one thing that I tried before this conference is getting this. So native image has one limitation. In theory, and there is a few, it's still in active development. It's getting quite close to being ready for wide adoption, I would say. But I tried a few Scala frameworks, and I noticed that the whole Scala community is not really trying to put these frameworks. We get now, these days, we get a ton of issues on GitHub, and like 95% of these issues are Java frameworks. So essentially, I tried a few Scala frameworks, and I found some things that are really not working, which we can fix in a matter of days. And I kind of noticed that essentially, the Scala community doesn't really know about this, or it doesn't want to try, or doesn't report issues. So this is our priority. Just open an issue on GitHub, ping if someone is not responding. We are very kind of overloaded these days. Say, hey, can you fix my framework? Sure, I will fix your framework. I will raise priority, okay? And others in the team, right? So it's kind of, I think it's important to report issues, test it in your CI. If you are a framework author of Play, just put native image in your CI, because it will also attract users to your framework, because others start up in 35 milliseconds and you don't, so it's better that you also support that, so you'll start in like 15 milliseconds or whatever. So put it in your CI, and that way it will keep it solid, right? And we provided all the flags and all the infrastructure. You can easily download native image, and you can run it, right? So just put it in your tests. And here we are actively working with the community. So just ping us on whatever means, like email, GitHub, whatever you want, we'll respond. Cool. So native image has another thing. So whenever it's kind of notoriously bad to compile Java and dynamic languages in an ahead-of-time way, right? So what we provided in native image is something called profile-guided optimizations, right? So essentially, the whole Graal compiler is built to know the profiles. You kind of run in an interpreter, you get what your application is doing, and then what happens is you basically get faster code, right? And we support this also with native image, right? It's called profile-guided optimization. So, but it requires you to build two native images. So you first do native image PGO instrument, you will get an instrumented binary, and then you take a few of your workloads. If it's a web service, just send a few requests. You will get your profiles, and then feed it to native image with this flag, and you will get an optimized binary, right? And what this gives us is that when we look essentially at the performance of native image at the moment, which has still a very low, like too many low-hanging fruit, so it will get way better. So if you get like this Apache bench, and you get the cumulative number of requests sent by Apache bench, you will see, in the beginning, of course, native image is the red line. It will be way better, right? Because it starts from the very beginning at full speed, right? And you will see that it needs about like 100,000 to 500 to 1 million requests for the hotspot to warm up all its stuff. And even when it's warmed up, it's just a tiny bit faster than the native image, right? And that's mostly because our GC is currently not the best thing in the world, and we are working on a new one. But basically, with native image and PGO, we will get basically, very soon you will get faster code than you would get by just running on JDK8, right? And it's also very important, the native image is cool for command line tools. So here on the right, you have it with PGO. For Scala in particular, because of all the abstractions that we remove, you will get actually faster code than on Hotspot. It's not only that it starts fast and it has low memory, but it will run faster, right? So Scala FMT is the best. I think it's like 37% faster than Hotspot. So it's not like, so if you want to format your files, in IntelliJ or whatever, it will just go through them in like 5 milliseconds, okay? Cool. So, now we are standing on the shoulders of giants, right? We have the Graal compiler, which makes stuff really fast. We have the native image to compile it into native code. And what's new, what we've been working in the last 6 months, is essentially to extend this picture with three new things. It's like deploying to mobile devices, right? So what we are building is deploying to iOS, Android, and desktop. And as a part of this effort, we tried a few things. We have a GraalVM. First of all, iOS is kind of the biggest problem because, first of all, it doesn't run on AMD 64, so you need like an ARC compiler. So we have two efforts. One is to use LLVM, and the other one is to use the Graal native compiler to ARC. So what we added is just for fun is to see how well would this LLVM work as a backend for native image. And what we've done is we implemented an LLVM backend for GraalVM, which is now merged, and it's there. It's kind of still not in the best shape, but you'll see it in the demo. It works. And why do we need this? One of the reasons is that Apple is constantly threatening that it will require essentially LLVM bitcode for the applications you ship to the iOS, right? So, then we can ship the LLVM bitcode and we're clean. In case, they pull the plug, we can always say, well, we ship the LLVM bitcode. And then another interesting thing that LLVM gives is that you can relatively easily port to new niche architectures. So if you're in the embedded market, like is it automotive or Internet of Things, you have some little kind of not so well supported architecture, you can just, and you have an LLVM backend, which is most likely, you can just generate that and you should be able to, with a few weeks or maybe a month or two, you should be able to get native image, so it means all Java and Scala programs running on your device, right? But it comes with a price. This is like not done yet. Moving GC in LLVM is still experimental, so I'll keep you posted, right? So we'll probably, when it's done, when we know exactly what's the story, we'll write a blog post about it and talk about it. So now let's see how this cross-platform Scala and Java, of course, it's the same platform will look like. Right, so we talked about GraalVM native image. Now we have all the bytecode compiling into the executable, which runs on any platform. What we did is now we need to do the front end, right? So how does the developer and which library do we use, right? So for that, we teamed up with this company called Gluon, and together we worked on this tool set, which is essentially consists, you start with your ID, right? And then you have a plugin, which is in our case, it's currently Gradle and Maven, but adding SBT, all the code is there. So just, someone can pick it up and make an SBT plugin. And then we come with this JavaFX mobile, which essentially contains all of the UI components that work on all the platforms. So they work on Android, iOS, and desktop, right? And all of that is kind of glued with Gluon tools, and the static libraries cross-compiled for all these platforms, and compiled with the GraalVM native image and set to your device, right? So you kind of get, a full-blown stack for development on mobile. And of course, with this Gluon stuff, you will get also extensions for all the mobile stuff, integration with the mobile devices, like abstractions for cameras, GPS, and all the things like that, right? And all of this is open source. This part, and a part of Gluon Mobile, there is a closed source part. That's the way how they earn money, basically. So they do some mobile-specific connectivity, and they do some libraries for this kind of cross-platform stuff. But essentially, everything you need is open source. So you can just start, and today you can come out and start hacking your cross-platform mobile app on the JVM. So I think I've said most of these things. Yes, so this was the only way, basically. Before, the JVM was locked because running hotspot is not allowed on iOS. No one has developed a proper AOT compiler. There were a few open source and a few commercial ones, but none was built on solid ground, right? With a proper team supporting it. So for the first time now we have a proper, ahead of time compiler for Java, so we can deploy to all these devices, right? And we can kind of spawn a new ecosystem based on Java. And then for JavaFX, yeah, it has native code, but JavaFX is not the only library in the world. There is others, which we'll talk about later. And yeah, this is all the things I said. And of course, this all works only for Java 11, 12, and 13, right? So Java 8 is not supported, so starting from Java 11, because JavaFX starting 11 supports all of the native stuff. And Android is coming soon. We are working on that. It will be in a matter of months out. So let's check this out. How does this work, right? So here we will have this chat app as a demo, which we developed in our IDE. And then, you will have just here is just a normal Gradle project, like anything else. And then what we can do is, while you develop, you can develop on desktop freely. So we can say just Gradle run. I will not compile here, and the reason for that is essentially that at the moment with this GraalVM stuff, it compiles way too long for this presentation to show. But yeah, this is an application now running on a desktop. It's a chat app. It's Hello Scala Days, GraalVM runs faster. And then you can send a message. Okay? So you can just go back to your IDE, hack stuff, Gradle run, and you get the app to run. Okay? Good. Now let's see what you're going to do for the device, right? Well, same project. You say Gradle native run, right? So of course, again, I skipped the compilation step because now it would take a minute or 2 minutes to build, so we don't have time for that. So what this will do is it will fire up a simulator. The simulator will go through the Gluon tools, and you can see that it sees this message. It actually downloads it from the internet, right? So all of this stuff here I am using is connected, so it's all in the cloud, right? So you will see the message I just posted. And because this is a simulator, you need to turn it off by clicking on this button on the side and then sliding off. Okay? And then, once you're done developing in this environment, you basically want to finally test it on your device. So you just change one variable. In this case, I copy the project. And then you will say, again, native run. And you will say, instead of iOS, you say iOS-sim, you will just say iOS. And then what this will do is, when I do run, if you can see, whoop, same two messages, right? So it's all connected to the same thing. And then you can basically start developing, right? Okay? Merci. Cool. So, and good. So, many, especially here on the Scala Days, I've seen people are using a particular trick to get away about this blocker that you cannot do JVM on mobile. And they're using Scala.js to compile Scala into JS and then hook into this React Native. So here I would just like to compare essentially, what I'm trying, what I would like to see happening is that essentially we spawn a JVM community around mobile, right? Because it's not that I don't like JavaScript. I think it's just good to have, it's good to have two things done, things done in two or more solid ways, right? And I would just like to compare React Native. And now at this point in time, we just started, right? So this was the hardest part. Getting this demo to run was the hard part. Of course, it's still buggy and stuff, but in a few months, it's fine. But now when we remove all of this noise, I want to just compare it to React Native and say what I think needs to happen. So if you now look at today, of course, React Native has 70,000 stars on GitHub or whatever. And because of that, because of this bigger community, it has more components which are developed. And it has another feature that we still don't have, and it's hot code updates. So, right, if you make a bug in your application, you can just send new code. Essentially, the code running on the devices, when you call functions, it will say, was this function updated? And it will download a new one from the internet, right? But then it's essentially interpreted code, right? So it's very slow. It starts up slow. It has essentially, for complicated apps, you won't be able to run them, and it burns battery, right? So, and for JavaFX, already in this state, first of all, you're running on the JVM. So you get like a humongous ecosystem of Java libraries readily available, right? In one of the demos, which, because of the GC that doesn't work or didn't make it, we can run actually the Scala compiler on the thing and show trees and print trees and so on, right? So you can just you cannot run Scala compiler with React Native. Sorry, it's not going to work, right? And then you will get way better performance, right? Because you're based on Graal, it's all AOT compiled. You get like a full JVM performance on your iPad. So basically, when you click on this app, actually downloads some stuff from the internet over my phone. So it's kind of waiting for the messages. But when you click on an app, it just like pops up, right? It's like no overhead. Which we've seen also with the microservices, right? So you get better performance and faster startup. And what needs to happen now on the JVM is like, there needs to be a community, right? You need people start hacking stuff up and making new libraries, right? And then it will be way better than React Native, right? You will get, a purely native app running fast with a better community. And Scala is an awesome language to start this, right? We've seen this before, right? There was this like Hadoop, and then there was Spark, right? And then Spark was written in Scala, and like, woo, and then like a million people like just talking about Spark around the world, right? There was the same stuff with Akka, right? There was Akka actors. There were actors before, but then Akka actors come, and then it was like, woo, crazy Scala, let's make libraries, and then like all of the Akka ecosystem was born, right? And similar with Play, right? And what I suggest to people that want to start these projects, I mean, these libraries like React Native and Flutter, they all already developed all of these native components, and they're all open source. I think so. I think people should just like borrow that on the JVM and kind of make a really nice library on top of it, so that we can start an ecosystem on the JVM, right? Yeah. So if you have free time, just spawn a pet project. You have a Gradle build, start from there, add a Scala plugin, and there you go. SBT plugin, slowly it starts. You know how it goes. It goes pretty fast. And what are our next steps on this project? We still don't support GC for iOS, so if you swipe through this app a bit, it will just like collect your windows. So that's not yet, but that's like a week or two work. It's not a problem. We need to do running on Android. That will take probably a couple of months. What we need to do is we need to use a Java bytecode interpreter for development, because at the moment, when I was compiling Scala with LLVM and JavaFX, it took 1,000 seconds last night. It's very fun, right? So we need to put the Java interpreter, so that's one of the advantages of React, is as you develop, you see your stuff appearing. We need to make the same thing happen. So we need the Java interpreter on an iPad or on Android, and you just need to ship your bytecode and see it right away. And of course, we need to do the support for Android. But these are our details. We'll take care of this. It's time to start hacking on this, basically, right? It's like this will kind of, in the beginning, every project is not perfect, but we'll be there really soon, like half a year or so. And this is kind of it. I would like to give special thanks to Johan Voss and Loic, who worked on this project. We kind of did it together. Loic is he's in Gluon, and essentially he worked with JavaFX, and this is the type of contributors that are best in the world. He just says, I want to contribute to these projects, and then basically in a couple of months you get all these pull requests. Actually, for his pull request, I made a meta pull request saying we need an automated bot that merges pull requests, because this is not possible for me, right? So, so I would like to give special thanks. A lot of this work was basically his stuff. And Loic, who did an LLVM backend, master student straight from university, just puts an LLVM backend that works. Pretty impressive. That's yeah. So to conclude, basically, I would just say two things. Don't waste energy, time, and money. Just put this on your Java class, on your Java, in your Java flags, And it's time to start a new community for cross-platform development. And I think Scala is the best place to start that. And you should just start here. It's this link. You follow it. You can, the same stuff you did here, you can do on your iOS device, right? So, and it's now time to start. We are kind of done with the hard part. Now it's just cleaning stuff up. Cool. Thank you. It's not over yet. I'll just answer with my son hugging me, if you don't mind. So do you have any questions?
Hello. I'm pretty sure I saw you at the SIGO conference, so it's good to see you again. I'm working at Twitter. We're using native image. If you saw the Qualia talk yesterday, there was a couple slides on how it's allowed us to essentially do remote compilations because we don't have to wait for a JVM to start up each time. We want to invoke a compile on a different machine, and that's very, very nice. And that's very cool, and I appreciate that a lot. I had a specific question, which was, if I, for example, were to 100% black box re-implement PGO and reference compression in native image, would that be a copyright concern, or would that be something that would be accepted by the Graal project?
It's a tough question. Thanks for asking it. So
it's not easy to answer.
It's not easy to answer. I don't think I'm in a position to answer. I think for these two particular things, I cannot answer this publicly. Next question. No, I think for these two things, in particular, I think they're not so hard to do. There is things which are very hard to do, and these things are moderately hard, right? So it would probably spawn a ton of discussion, but there is a chance of this going through, I would say.
That's really good to hear. Thank you very much.
Yes, there is a chance, but I cannot, of course, I'm not completely not in a position to say. It's just like my gut feeling, because it's not really, it's not really the core thing which is hard, which is we are keeping closed source.
Thank you for answering that. It may have been a bit of an unfair question. But I really appreciate it.
It's an unfair question, but I give you my, this is a completely personal answer, a gut feeling. Yeah, it's like.
Thank you so much.
Yes.
I didn't understand how the native image reduces your memory footprint.
So what happens when you start Java? It essentially does a lot of things, right? It starts loading classes from disk, which are kind of not in an optimal format. Then you start interpreting those classes, right? So you need an interpreter, and an interpreter generates a ton of garbage and stuff. Then you need to profile that as well, right? So you need a profiler, and you store all of these in memory for every method that you run. Then you need a C1 compiler, which compiles so you can get faster warm-ups, so you compile once, right? And then after 10,000 times, you need a C2 compiler, which compiles to a final version of your code, which is optimal. So you need, two compilers, one interpreter, one profiler, byte class loading, and it's an open world, so you can only, it's all, you don't know what's where, so you kind of need to keep like massive data structures for all of that, right? So that's essentially why it's, Yes. Yes, that you can basically done in advance. All you need to do is throw away dynamic class loading, right? So you cannot download a jar from the internet and run it on native image, right? So this excludes some things like SBT, for example. If you want a native image of that, that's not possible, right? It will download plugins with different versions. It becomes a combinatorial explosion of like jars that you need, right? But if you have your microservice, if you have your command line tool, if you have a mobile app, fine. Yeah. You just put these jars on the class path, you do a bit of configuration, and you're done, right? Yeah. Thanks. Good question.
Really quickly, I don't necessarily know about SBT specifically, but we in Pants have been able to generate native images dynamically from jars that we've downloaded and then built into new images. So definitely dynamic class loading, definitely isn't there intentionally, but we've been able to work around that at the build tool level. So it actually is potentially possible.
Can you open source that, right? That's the
Yes,
yeah.
everything is open source.
Can you put this out, right? That's what we need, right? If you could make a Scala compiler for your macros and your project and do PGO on top of it, you would get the Scala compiler that's faster than Hotspot and starts immediately. Right?
That's what we're doing.
That's what we need.
That's 2018 Scala Days presentation about GraalVM. We're using that directly. So thank you, whoever did that, for doing the hard work.
Yes, I was hoping last year when I gave a presentation this will happen, and you see, voila. Yeah. Wow, amazing. Thanks.
Short question. I didn't understand why is the Graal E edition slower here, sorry, than the C edition? Is it just some optimizations which are not active, or? Yeah, there's a lot of optimizations in enterprise, right, that are not active, and they're not easy to do. It's like, it's a lot of optimizations, right? Yes. Yes.
So no more questions here. Thank you very much once again.
Thank you.